In this video, we demonstrate how to build a carbon nanotube structure. We begin at the TubeGen website, hosted by the University of Delaware. It allows you to generate structures for nanotubes. On the site's main page, we've changed the chirality fields to 7, 0. We also changed the cell replication count to 1, 1, 4. Other than that, we use the default values and then click the Generate button. Doing so displays the generated structure in a new browser window as plain text. We select all of this text and copy it to a text editing application on our local computer. We then save the file in a convenient location for further work. Be sure to save the file as a GJF so that GaussView can read it. We will use GaussView application to make modifications to the structure and to set up the Gaussian calculation. We open the file we just saved in GaussView. Our first modification is to remove some of the carbon atoms from the end of the tube. Specifically, we will remove 1 row from one end and 3 rows of carbon atoms from the other end. Reposition the nanotube structure within the view window in order to make selecting the desired atoms easier. Then we use the marquee selection tool to select 1 layer from the right end of the tube and 3 layers from the left end. This is how the view window appears after all are selected. In order to delete the selected atoms, we use the Cut item in the Edit menu. We now need to add hydrogen atoms to the outermost carbons at each end of the tube. We'll be adding a total of 7 hydrogen atoms to each end. Use the Add Valence tool and click on each relevant carbon atom in turn, rotating the tube as necessary as we go. We'll repeat this process for the carbon atoms at the other end of the nanotube. At this point, you may be tempted to clean the structure. Many people have a habit of using the clean function frequently as they build a molecule. In this case, however, you don't want to do that. We'll show you why by clicking on Clean Now. Notice how the tube structure becomes very distorted, much worse than before the clean. Therefore, we will undo the last operation. Our approach to refining the structure is to use GaussView's point group symmetry feature. We will impose D7H symmetry on the structure. We open the point group symmetry dialog and enable the symmetry. Then impose D7H symmetry on the structure, loosening the detection criteria as necessary to get the desired results. The structure is now complete, and we can go on to set up the Gaussian calculation and then run it.